When we talk about AI, we get really excited about these massive, powerful models and super smart algorithms. But today, we're going to pull back the curtain on the process that actually makes it all possible. It's not the flashy part, but trust me, it's maybe the most important part of the whole equation, the data refinery. So you've probably heard this phrase a million times, data is the new oil. And look, it's a great metaphor, but it only tells half the story. Raw crude oil is super valuable, sure, but you can't just pump it straight into your car's gas tank, right? It has to be refined. Well, data is exactly the same. In its raw form, it's just a messy puddle of potential. It needs to be processed before it can actually fuel our AI. And this, right here, brings us to the first and maybe the most important law of the entire AI universe. Garbage in, garbage out. It's that simple. An AI model can be the most powerful engine ever built, but if you feed it low-quality, dirty fuel, in this case, messy data, you're going to get junk. Unreliable, biased, sometimes just plain wrong results. The quality of your output depends entirely on the quality of your input, period. And that's why we say data is truly the foundation of all machine learning. It is the bedrock that everything else is built on top of. I mean, think about it for a second. How does an AI actually learn anything? It digs through mountains of data looking for patterns. Whether it's trying to tell the difference between a cat and a dog, predict the stock market, or figure out what you want to buy next, the data is its textbook. It's the study guide. Without good, clean data, the model just can't learn the right lessons. Okay, so what does this raw crude oil of data actually look like before it hits the refinery? Let's dive in. So raw data really comes in two main flavors. On the one hand, you have structured data. This is your neat, clean, easy-to-read stuff. Think of a perfectly organized spreadsheet with rows and columns like customer records or financial reports. And then you've got the Wild West, unstructured data. This is the chaotic, beautiful mess of everything else. All the images, videos, emails, and social media rants. Both are incredibly valuable, but that unstructured stuff, well, that takes a lot more work to tame. All right, so how on earth do we deal with all this messy, raw data? This is where the magic happens. This is where we step inside the data refinery. The technical term for it is data processing, and it's the absolutely essential process of turning that raw sludge into high-octane AI fuel. Look, you could call data pre-processing the unsung hero of machine learning, seriously. It's all the work you do to clean, organize, and structure your data so that the algorithms can actually make sense of it. Without this step, pretty much every major AI project would be dead in the water before it even starts. Okay, so let's take a tour of this refinery. What are the big impurities that data scientists are constantly fighting against? We're going to look at the big four. First up, the classic problem of just missing stuff. What happens when your data has big ol' holes in it? This happens all the time. Maybe there was a glitch during data collection, a system crashed, or maybe someone just didn't feel like filling out a field on a form. Whatever the reason, you're left with empty spots in your dataset. This is what we call, simply enough, missing data. And you can't just ignore the blanks, because then you're throwing away valuable information. So data scientists use a clever technique called imputation. It's kind of like being a detective, using the clues from the data you do have to make a really smart statistical guess to fill in those blanks. Okay, problem number 2 is a little sneakier. What happens when all your data is there, but it just doesn't agree with itself? It's full of contradictions. Yeah, this is what we call inconsistent data. Just picture this. You're trying to merge two big customer lists. One database uses M and F for gender. The other one spells out male and female. Or maybe someone just fat-fingered a keyboard and spelled a city name wrong. Now, to you and me, that's simple. But to a computer, M and male are two totally different things. It gets confused. So cleaning that up is absolutely critical. All right, our third impurity is all about the weirdos. You know, those data points that just stick out like a sore thumb and make you go, huh, what happened there? These are called outliers. An outlier is a data point that is just wildly different from everything else. You know, maybe a faulty sensor records a crazy temperature, or a simple typo says someone's age is 250, or maybe it's actually something real and important, like a massive fraudulent credit card transaction. Either way, these outliers can totally throw off your entire model, so you have to handle them with care. And dealing with these isn't just a guessing game, it's a real scientific process. First, you have to detect them using charts and stats. Then you play detective again. You investigate where they came from. Was it a mistake or something real? Then you have to decide how to treat it. Do you remove it or adjust it? And finally, you document everything you did so other people know exactly what choices you made. It's a system. And now for our last big impurity. And trust me, this one is a doozy. What if your data, even if it's perfectly clean, is just fundamentally lopsided from the get-go? This is a huge problem called data imbalance. Let's say you're building an AI to spot a rare disease. In your data, 99% of people are healthy, and only a tiny fraction are sick. What happens? Well, the AI can be lazy. It can just learn to guess healthy every single time, and boom, it's 99% accurate. But it's also completely useless, right? It fails at the one job it was supposed to do. That's why rebalancing the data to pay attention to those rare cases is so important. Okay, so after all that hard work, all that cleaning, fixing, and balancing, what's the point? Why does all this tedious refining actually matter so much? The payoff is huge. You get that high-octane fuel for your AI. This means your model is going to be way more accurate. It means you get a model that's more fair and trustworthy because you've weeded out those hidden biases that can cause real problems. And it means you can actually understand why your model is making the decisions it's making, which is absolutely crucial. And let's be clear, this isn't just some abstract academic idea. This process powers the AI systems we're starting to rely on every single day. We're talking about fraud detection that can actually spot that one needle in a haystack transaction, medical models that can catch a rare disease early from a scan, business insights that are actually insightful. Clean data is what drives progress. So, all of this leaves us with one big question to chew on. In this day and age, we are absolutely swimming in data. It's everywhere. So maybe the real challenge, the real frontier for AI right now, isn't finding more data, but getting better at refining the data we already have. Something to think about. Thanks for tuning in.